Welcome to lecture Electrical Energy Conservation. Energy conservation, a case study. Energy conservation, the PPT, the presentation contains energy scenario in India, energy flow, then system efficiency, need of energy conservation. So by studying these three topics, we come to know what is the need of energy conservation, then case study and conclusion. Energy classification, primary and secondary energy. Primary energy is the energy which is available in nature, and secondary energy is the energy which is converted with the help of some conversion facilities like electrical energy. Steam is the secondary energy. Renewable energy and non-renewable energy. So in India, most of the energy which we are getting, electrical energy, it is from the fossil fuel. Around 60 to 70% energy we are getting from the fossil fuels. It may be the thermal power plant, nuclear power plants, gas power plants. Whereas a large number of solar energy or renewable energy has been established. And now still the renewable energy rooftop solar plant, or it may be the wind power plant, still it is in the installation process. Now this is the energy scenario. This is the our primary energy, and this is the secondary energy, or after conversion of the from primary to the secondary energy. Let me start from the coal. India is a coal-based country. So most of the coal is utilized for the conversion of electrical energy with the help of a thermal power plant. So coal, it is going to convert, most of the coal is going to convert into the electrical energy. Some of the coal is used in the coal burner in the different industry for the utility purpose, steam production of steams and for the different application or the process. Whereas the nuclear, entirely it is used for the conversion of electrical energy, renewable energy also used for the energy, electrical energy conversion also in the heat conversion. Now gas, we are using gas in the gas burner, and different type of gas burner we are using in the cooking application and many of the industries also, whereas it is used for the energy conversions also. Next is the biogas. Biogas, very little bit is used for the conversion of electrical energy, but most of the biogas is used in the biogas burners. Next is the oil. We are importing from the Middle East, and most of the oil is used for the diesel engine, petrol engine, it may be aircraft and oil burner. Most of the coal burners or the coal boilers, they are replaced by the oil fired boilers. And very few oil is used for the conversion of electricity as a power backup. We are having the diesel generator as a power backup. Whenever grid fail to supply, we used to run our diesel generator to maintain the electricity in the premises or in the industries or at all. So this is the present scenario. Most of the energy it is going to produce by the coal, because the coal is large number of coal pits are available, and hence we are converting this primary energy into the secondary energy. Now this is the history of power plant. Just it is in brief. It is some say Edison has installed 100 kilowatt. Edison company has installed 100 kilowatt solar plant, and Westinghouse Tesla, it is very much, he is very much interested only for the AC transmission. Therefore now the AC transmission, it has some numerals, means it is having some advantage as compared to the DC transmission earlier. Now, during independence, we have only the installed capacity in India, it is 1.302 megawatt. And now the installed capacity is 200 times or more than 200 times as compared to 1947. Now, this is the path. Now we have installed the Damodar Valley corporations, then thermal nuclear power plant, of 320 megawatt is the first nuclear power plant in Tarapur. Then establishment of NTPC and NHPC, then Rajasthan nuclear power plant, and so many other thermal and other say hydropower plants. And in 2020, PV solar plant in Rajasthan, it is 2245, means 2245 megawatt peak capacity it has been installed. So now there is a mix of thermal, nuclear, wind and solar, and this is the fossil power plants in up to the 2023. This is the fossil power plants capacity, and this is the non-fossil and total capacity and generating energy generation from this one. So this you can see again, the power plant capacity from the fossil fuel is very large as compared to the non-fossil fuels. That is the convention renewable energy. Now energy flow. Say primary energy is our coal, water, oil, and solar is the primary energy. This primary energy is get converted into the energy conversion facilities. So power plant is the energy conversion facility. Oil refinery is the energy conversion facilities available across the India. Now, after converting the primary energy, we get into the secondary energy. The secondary energy is electricity, refined oil, it may be a petrol, diesel, kerosene, is the secondary energy. And electricity also the secondary energy. Now, this secondary energy conversion from the conversion facilities, it is get transmit or distributed by the different ways. As a electrical energy, it is get transmitted by the transmission conductor and distribution network. And whereas if it is a oil, if it is a other secondary energy, it is get transmitted by the train or by the lorries. Now this is the final energy that what the consumer buy, either from the franchises, distribution franchises, say in Maharashtra, it is MSDCL and some other franchisee in the across the country, or there may be a petrol pump, it may be some, all these things, it is get the final user, final energy, what the consumer buy. Now it is utilized at the utilization level, say it may be a motive power for the motors, it may be automobile, it may be a lamps. So this is the energy utilization, and useful energy is the motive power. This is a spelling mistake. Okay, so there is a motive power, illumination, heat. It is we are going to convert. Now the system efficiency, the same things which we are considering, the flow of energy. We are going to consider what is the efficiency of the different stages. Say coal, we have taken as a fossil fuel, and we are using some thermal power plant. Say, for example, thermal power plant, and the final user is the pump, or it may be the agriculture pump. So coal is the primary energy. It is get converted into the secondary energy with the help of power plant. So first, the coal is transported from coal mine to the power plant. So the efficiency during this one, or there's the losses is 10%, and 90%, whatever the coal available from the coal pit, it is 90% coal is reaching to the power plants. Now the power plant, thermal power plant capacity, thermal power plant efficiency is hardly 30 to 35%. The reason is that there is a large number of auxiliaries. The say, for example, coal handling plant, coal crushing plant, then economizer, air preheaters. There are a number of pumps are there, and at the same time, there is a cooling tower and all these things. So the number of logs, because of this number of auxiliaries which is going to use for the running of thermal power plant, the efficiency is very small. The efficiency of boiler is still itself is very small, even though the generator efficiency and transformer efficiency is very good, but the overall efficiency, because of the this thermal consideration, that all so boilers and so turbines and all these things, the efficiency get decreases. Now, once the power is generated in the power plant, it is get transmitted and distributed in the network by the network. So the efficiency of the transmission and distribution network, it may be the primary transmission line and secondary one. The efficiency is 78%, means nearly 22% energy is going to loss. That loss may be the power loss, or it may be theft, that is economical and technical losses are there. Now, this is the final energy which the user or get from its doorstep. Let the user is using some pump, motor pump set. So the no doubt the motor efficiency is 70 to 88%, whereas the efficiency is 60% or 75%. So if there's a motor pump set, the entire efficiency it becomes hardly 70%. So now we can observe from this one, the efficiency is go on decreasing, and therefore the at the user end, we just say that if the energy generated in the generating plant is 4 unit, the user receive only the 1 unit of electricity. Or from the primary energy to the final user, there is a 1/4 of energy is going to reaches to the user end. Now, from this one, we conclude that the energy conservation is important. By doing the energy conservation, definitely we can save the natural resources, or energy conservation is nothing but the energy generation. We can avoid or we can delay the expansion in different type of plants. So what is the energy conservation? So energy saving without loss of quantity, quality, and comfort level is the energy conservation. Only by switching off the supply, switching off our appliances is not the energy saving. So we want the saving without loss of quantity. If suppose this is the production facilities are there, so the production quantity should not decrease, their quality should not decrease, and the comfort level. So in short, the energy saving without loss of quantity, quality, and comfort level is the energy conservation. Now the finite planet, that is our Earth, cannot support infinitely increasing consumption of the resources. Hence, the motto of present time must be reduce, reuse, and recycle. Definitely, whatever the natural resources are there, definitely it is going to vanish. So our this finite element, a finite plant cannot support infinitely increasing the consumption. Nowadays, the consumption of electricity, consumption of energy is gone increasing in every sectors. The energy conservation is a social issue and answerable to the next generation. So if you are doing energy conservation, what is the final result? The final result is the reduction of gap between demand and generation. So we are going to reduce the demand, enhance the gap, and we are going to bridge the gap by doing the energy conservation. Otherwise, we have to increase the generation facility, and increasing the generation facility is not so easy, because it requires capital, it requires the natural resources, it requires the land and many things. So the best way is the saving of electricity without loss of quantity, quality, and comfort level. That means is the energy conservation. This is the need of energy conservation. Now, energy conservation benefits. What are the different benefits of the energy conservation in the 3 domains? First is the customer, utility, and society. For the customer, satisfied the electrical demand. If our demand is more and generation is small, definitely there is a deficit, and because of deficit, consumer has to face load shedding. So if we do the energy conservation, the consumer side, the satisfied the electrical demand, reduce and stabilize the cost of electricity. Otherwise, the cost of energy is gone increasing. Maintain and improve the lifestyle and productivity. So if the 24-hour energy is available, one may say plan it's a production, it's say work as per the this one. Otherwise, it is very difficult to plan the activity because of uncertainty in the power supply. And from the utility, that is the generation, transmission, and distribution. So these three sectors get the benefit of energy conservation in the three points. That is the lower cost of the service, improve operating efficiency and flexibility. Definitely, the power is available. The utility is flexible to give the extra demand, and it improve the say production across the country. So for development of the country, energy is very important. Improve the customer service. This is the third. And for the society, reduce environmental degradation, conserve the resources, and protect the global environment. So if we are doing the energy conservation, means we are saving the natural resources. And once we are saving the natural resources, we are not burning the coal. Definitely it help in the improvement, or it is reduce the environmental degradation. Now, energy conservation and what is their potential in the different sectors. In industry, up to 25%, there is a potential of energy conservation or energy saving. In the transportation, it is 20%. In agriculture sector, it is a 30%, and domestic and commercial, it is 20%. And if you look at toward the type of industry, the energy conservation is more where the consumption is large. So definitely the iron and steel industry, the electrical consumption is very large. Therefore, the potential of saving also very attractive. So in the iron and steel industry is a 10%, whereas in the fertilizer 25 and textile industry is a 25%. So these are the some potential, or then there is some thrust area where again we can do the energy conservation. Energy conservation in India, the progress made by India in the energy conservation can be seen in the following three areas. One is the policy and institution, second is the end user, and third is the technology. Policy and institution is that India made some policy for the energy conservation, and there are some institution, it may be the financial institution, it may be some institution which help in the production to produce, or it will give the guideline to produce energy efficient machinery, energy efficient gadgets. So these are the policy and institution. In the policy, there may be the short term policy, long term policy, and it may be the medium term policy as per the some research and development is there. There these policies are made. For that purpose, Energy Conservation Act has been passed, and under some institution like BEE, Bureau of Energy Efficiency, and other bureaus has been established for the to look after the energy conservation and their gadgets, their efficiency. End user, the end user, it is necessary to educate the people, those are using the electrical energy. What is the objective of energy? It is not only to reduce our electric bill, but reduction of electric bill by the ethical way, not by the theft, not by the some different methods. So it is necessary to educate the people. It is necessary to give some advertisement or some seminar, some other way for that one. And technology. So we should adopt the technology which will reduce the energy consumption. It is able to produce the energy efficient machineries, like it may be a pump, it may be a motor, it may be a fan, lighting system, it may be a compressor, and all these things. Now, the technology, what the help in the technology, this is the street light replacement in the municipal corporation, which I have done the analysis, and the same things means in my what I have submitted the proposal or energy conservation some calculation, the same has been reflected in the Jalgaon corporation. Earlier in the old establishment in the corporation, for street light is like that, there are different type of lights are there. That is the tube light fitting, high pressure mercury vapor lamp, high pressure sodium vapor lamp, some T5 fitting, simple tube light fittings are there, and these are the their quantities. So this is the wattage of the lamp. It may be a 70% HPSV, then HPSV is a 150%, 150 watt, 250 watt, 250, 400 watts are there, and their quantities. Energy consumption, as per this one, is the per day consumption is 12,942 units are going to consume per day. Now, this is my proposal. I have proposed the LED lamp. This is the replacement. This is the example of technological advancement. So instead of using the tube light fittings, high pressure mercury vapor lamp of 70 watt, there is 48 watt. Similarly, 250 watt high pressure sodium vapor lamp, it can be replaced by 120 or say 150 LED lights. So these LED lights I have proposed, and from this one the consumption reduces per day is 7,800. So the percentage saving is 40%. And the saving in kilowatt, that is the total number of units, is 5,142. Similarly, because of this total capacity, the installation, the maximum demand is more, and here the demand is get reduces. So again, there is a reduction in the maximum demand, improvement in the power factor, reduction in the losses because the current in the distribution section is got reduces. So these are the some way by improving by replacing old machineries by the new machineries, that is the technological advancement. Now, case study. The case study for our college, it is a SSBT COT Bhamburi, Jalgaon. The energy conservation we have divided into the three parts. One is the immediate term, second is the medium term, and third is the long term. In the medium term, that is a demand side management, power factor management, and optimization or optimal utilization of existing installation. Whatever the existing installations are there, it should be used very optimally. It is we can do the demand side management, that is the some load management, because it does not need any investment, only we need some modification of the load, modification of the time of use of the load, only this one, and power factor management. In the medium term, we have replaced the inefficient electrical machineries by the Energy Efficient Bureau of Energy Efficiency mark. It may be 5-star, it may be 3-star. Whenever there is a replacement is there, whenever there is a renovations are there, the light fans has been replaced by the energy efficient. And in the long term, there is a captive power generation by the renewable energy. So there is a 295 kilowatt solar rooftop power plant. So this is the 3-1. Immediate. So we have maintained the power factor because we get the power factor incentive from the MSDCL in the local grid, from the grid supply. So in year 16-17, the average power factor is 0.995. The required power factor is unity, but it is highly maintained, it is 0.995. And we get the benefit in the form of incentive, it is 3,62,616 in the year 16-17. This amount is get reflected in the electric bill. Similarly, it is year 17-18, the power factor is 0.996, average power factor for the entire year, and we received the incentive 4 lakhs. Similarly, in the 18-19, 19-20, the power factor is 0.983 or 0.996, and again we receive this much amount in the form of incentive. The total incentive for this 5-year is 11 lakhs, whereas the cost of automatic power factor controller is not more than 70,000 earlier. Now, year 2021, there is a KVH billing. So in the KVH billing, the power factor incentive and penalty get merged in the KVH billing. This is the electric bill. So you can find here, this is the power factor. This is the average power factor for this month, 0.997. And this power factor penalty and incentive. This is the power factor charges, power factor incentive. So it is a minus sign before 19,000. So it means that it is the incentive from the MSDCL. So this is the energy bill. Now, medium term. In the medium term, we have replaced the inefficient machineries, inefficient electrical gadgets by some efficient or some alternative source of electrical energy. Earlier, we are having some kind of water heater, storage type water heaters in the different area, and it is very difficult to maintain this time of operation. Second is the maintenance. So the best option is the replacement of the electrical heater by the solar water heater. So we have installed the solar water heaters in the different sections and different time. So boys hostel number 1, boys hostel number 2, girls hostel, Professor Carter. The total capacity, presently the total capacity of solar power, solar water heater is 19,500 LPD, liter per day. And energy conservation or energy saving from the replacement, it is 68,000 per month. So very attractive, and no doubt the cost is somewhat high, but definitely it is safe to use. There is a no chances of electricity shock, because once we repair the electric geyser or electric heater, there may be a chances of current leakage and electric shock. Whereas in the solar water heater, it is quite safe, and the operating time is not necessary to keep the operating time. It can be used at any time. So this is the solar water heater which installed over the roof top of the different hostels and building. Now replacement of LED lamps, replacement by the LED lamps and use technology, the which we have discussed in the B is the end user. So these are some locations. Earlier we are having our conventional lights, say for example college main building, 36 watt light plus 14 watt choke is there. College main building classrooms are there, so there are 36 watt tube lights. The quantity of lights is 100, 500. Similarly, in the computer lab, outdoor and playground. In the outdoor, we are using 150 watt HPSV lamp. And similarly, in the playground, 400 watt HPSV lamp and mercury vapor lamps we are using. These are the quantity. And the connected load, these are the total connected load in this area. So in the 39.8 kilowatt. Now this uh, conventional light are replaced by the LED light. So now here 28 watt, here 22 watt LED lamp. So there is a reduction in the capacity of lamp, reduction in the connected load. Similarly, here we have used only the 15 watt instead of using 40 watt tube lights. In the outdoor street light, it is replaced by the 48 lamps, 48 watt lamps, and in the playground, it is 400 watt. It is replaced by the 70 and 100 watt lamp. So it is found that the average percentage of energy conservation is 56%. So this is the second way. Now, long term. In the long term, the college has installed in total 295 kilowatt solar plant. So this is year 21-22, the energy consumption. So the green color is the energy generation by our own solar plant. Energy from MSDCL means grid, and this is the total energy consumption. So see, in the year 21-22, this is our energy generation from the rooftop solar plant, whereas this is the energy purchase from the MSDCL or grid, and this is our total consumption. So here, the most of the energy, around 70%, this is for the year 21-22. No doubt, this is we have a capacity is more. So entire energy we have taken from our own solar power plant, and very few energy we have purchased from the MSDCL. Now this is the energy for the last 4 to 5 years, energy from the grid and PV solar plant. In year 16-17, we do not have any type of renewable energy. In 17-18 also, but in March 2018, we have installed our first 100 kilowatt solar plant. So this is the 1,41,000 unit is from our solar plant, and this is the energy purchased from the MSDCL. In year 2019-20, the next solar plant of 95 kilowatt has been installed. Therefore, the share of energy is increased from the solar energy. In year 2021, this is the pandemic period. No doubt we have a large amount of energy generation, and the energy from the MSDCL is very small. In year 21-22, the third plant of 100 capacity, 100 watt peak capacity has been installed. So total capacity become 295 kilowatt. So entire energy we are having the energy from only the solar plant, and some of the energy get feedback is given to the grid as a bank energy. So this is the PV solar plant. It's a rooftop solar plant on the top of the main buildings and electrical department buildings. Now, energy conservation case study here we can see energy by the PV solar plant in year 22-23, that is the end of March. It is 14,83,926. Till date means up to the September, up till the October, the total energy generated from the plant in the 4.5 year, it is 14,84,424 kWh. These are the number of units. Almost near till the end of this month, almost it is a 15 lakhs. And energy bill saving in term of rupees, it is 1 crore 94 lakhs. So it is hoped that at the end of this financial year, we save electricity bill up to the 2 crore. So now our break-even point is there, and definitely it is already covered our investment, and we are still in the profit business. Now we conclude. It is not a conventional way for the conclusion, but it is some 4 lines, 3 lines are there as a conclusion of entire topic as energy conservation. If we want 1 year prosperity, grow green. It's very simple. If we want 10-year prosperity, grow trees. And if we want 100-year prosperity, conserve energy. Thank you.